Alright, welcome back. In this video we're going to look at our programming workflow, and this is the way we go about programming, because a lot of students make a very bad mistake and do this wrong, and they end up finding programming really hard, and also in turn getting low marks or failing the subject. If you follow this correct workflow, you will find that you are learning a lot quicker by reinforcement. So it's a reinforcement learning style, and also your programs will work quicker and have less logic errors as well as compile time errors. So what most students are used to and where this mistake stems from is when we write essays, we usually write the whole thing out, and then at the end we'll go back and proofread it. We can use our autocorrect, which we do at the end on Microsoft Word, and we can fix up all of our spelling and grammar, and then we can proofread it again and proofread it again and fix it after we've written all of the work. Now, if you try and do this with programming, okay, like we've got here, so if you write a whole heap of code and then you go and compile, okay, so compiling means turning your code into an executable, you're going to get a huge list of errors, okay, just because firstly it's inexperienced, but secondly even someone that is experienced would likely expect a huge list of errors if they hadn't compiled after writing a lot of code. It's unprofessional to work with this workflow as well. So even professionally, this is a bad workflow that we've got up here. And because of this huge list of errors and this pretty garbage code, most students find programming hard because they've written code that they don't understand, and they've got a huge list of errors that they don't understand, and so programming is really hard. Okay, and it's understandable if you follow this workflow that programming is hard. So instead, how we're going to program in this subject, and the way that it's expected that you program in this subject and into your professional life, is what I've got here. Now this can be changed up a little bit when you've got more complex test cases and things like that. And it excludes warnings, which we'll talk about later. But this is the basic structure that we want to work with, and we want to do it right from the start. And we'll look at that when we write our first program in the next video. But this is more important to start with than just looking at a program. So this is generic and works with any programming language. And also other problems. So if you're doing networking or something like that and it's not even programming, this still applies. So what we do is we start here, okay, and we write a little bit of code. Now, a little bit is not well defined. Basically, we'll show you what we mean by a little bit of code in the next video. But basically it means that your template is a little bit of code, and then every line inside of that is pretty much a little bit of code. So you're going to be compiling a lot. And it might seem slow that you're compiling a lot, but it's going to save you a lot of work. So we take our little bit of code that we've written and we go and compile. And we'll see this in the next video and how this compiler works. But this takes your little bit of code, which is just text, and turns it into something that'll run, so an actual program. Now the compiler checks for errors, because if it doesn't understand what you wrote, it won't know how to turn it into a program. So if you've got errors, you need to fix the errors straight away. Now, because you've only added a little bit of code, you know exactly where your errors are. And so you can go and fix them quite easily. So you go and attempt to fix them, and then you compile again. And if it comes up wrong again, then you keep applying different fixes until it works. So if you're doing your programming wrong, this is reinforcing your learning such that you're learning from the compiler. And these are things that you cannot learn from a lecture. These are things that you learn from making mistakes and reinforcement. And if you keep following this structure, by the time you get it right, you understand that line better than anyone else. If you do get it correct, then we need to ask the question, is it testable? Now, a program is only testable if it's got some output that we can do something with. Now, for our case, this is going to be mostly text to the screen. We will see more complex outputs later, but at the moment it'll be text to the screen. And for us, this will be our printf function. So if we have no printfs in our program at this stage, then it's not testable. And the reason that we need to check if it's testable is because if I enter the value, let's say I've got an addition program and it adds two numbers together, and I give the program a 1 and a 2, but the program doesn't print anything yet. How do I know if it works or not if it doesn't give me a value back? So I can keep giving it values, but if it doesn't give me anything back, it could work perfectly, it could not work perfectly. I'm completely blind to what it does. So if it's not testable, then we keep writing code and following this structure until it is testable, until we can print something to the screen. So we keep adding our little bits of code, one line at a time, and keep going up and checking for errors and fixing those errors as soon as they occur. Once we have something that's testable, so something printing to the screen, then we can actually run our program. So by running our program, we can see what it does, see what outputs it gives us. If we give it something, does it give us something different? Early on, we're not going to have any inputs, but when we have inputs, we can try lots of different tests. So we run this program and it prints something to the screen, or it might crash. So when it crashes, we have runtime errors. Now, this early in the subject, you shouldn't have runtime errors. But what you'll likely come across is logic errors. Okay? So let's take my addition program, for example, and I give the addition program the number 1 and 2. And I'm expecting the number 3 to come out. But the program gives me, let's say, 800. So it compiles perfectly fine. Your syntax, your understanding of C is perfectly fine, but your understanding of the problem is incorrect. And so you have a logical error here. So the program runs, but it gives you something that's garbage. It gives you something that is not what you want. So you need to go back and fix the logical errors. Now, the tricky thing about this is the compiler doesn't care about logical errors. If you've got a logical error, the compiler will not tell you that you've got a logical error. You need to test that yourself. Now, if you have no logical errors, so if this gave me 3, after I fixed it, compiled it, and so on, then I need to ask, am I done? If I'm not, then I keep going. Maybe it prints goodbye at the end or something. So I need to add that line of code. And if you are done, then you can submit, do whatever you like with it, publish it, etc. This is the structure you need to follow if you want to do programming in any subject, field, well. Do not do this. You are just going to make your life really, really difficult and you'll really hate programming. If you follow this, you will learn quickly and you will also have programs that you can submit. And that's really, really important. Alright, so that's it for this video.